Going to carry out a simple insulation resistance test, just on a test rig really, just to show you to go through the process, maybe to find a fault if we have to. For this test I'm going to use a Mega MFT 1730. It's a multifunction tester and it does everything I need to do. First of all though, we need to carry out the basic preliminaries. We need to make sure that the test instrument is in good order, it's not broken. I need to check that it's accurate. Well, this is my test instrument, and I know it's accurate, but we're not necessarily looking for a calibration certificate. We need to know that it's accurate and it's been checked at regular intervals. The next thing we need to do is ensure that the leads are to GS38, because this test is going to be a 500 volt test, and every time I do a test on anything over 50 volts, my leads really need to comply with GS38. So I've looked at the machine, the tester, I've looked at the leads, I know they're okay, they certainly comply with GS38. Now I need to check that the instrument is functioning correctly. So all I need to do for that is to join the ends together, push the test button, and I can see that this has gone to 0. That tells me that these leads are in fact complete and there's no breaks. Not a bad idea, just to test it again with the leads apart. And now it should be reading over range, which on this machine is greater than 999 megohms. I've now checked the machine's working. I know the leads are okay. Everything's in order. So now I can proceed and carry out the tests. So I need to set it to 500 volts. Test between live conductors. Push the button. And with any luck, I'm going to get over range. It's only a small installation, so 999 megohms, that's perfect. I now need to join the live conductors together. Okay. Tested together to earth, take a reading, and lo and behold, I can see I've got a fault. So in this instance, it wasn't a shortcut, because now I need to test them individually. So I go between my line conductor to earth, take a reading. I've got a value of greater than 999. Connect to the neutral, take a reading, and I've found my fault. So my fault is on the earth to neutral, and it's a 0, so that would represent a short circuit fault. The only way I can identify this fault now is to take the board apart and take the neutrals out of the neutral bar. It's very important when you're fault finding to work methodically. Now, obviously I've no idea which circuit the fault's going to be on, and I've got a choice at this point. I can start from number 1 and work along this way, or I can start from the one nearest me and work back. The worst possible thing I could do would be to start in the middle somewhere, just taking random neutrals out, hoping I'm going to come across the fault, because by the time I've done 2 or 3 circuits, I'll have forgotten which ones I've done. So it's far better to work methodically. Because it's nearer to me, I'm going to take out the circuit that's nearest to me. And now I'll do a test. And I've still got the fault. So clearly, it's not this circuit. So now what I need to do is put that one back and take the next one out and just work my way along. I've worked right the way along, I've tested every circuit, still got the fault, so I've now taken the last one off, and if this isn't clear when I push the button, obviously I've got a fault and I need to go back to the beginning and start again. And at that point, I would probably take them all out and put them back one at a time just to see what happens. So here we go. Okay, so the fault's clear. I've got a value now of 999 megohms, so that's telling me that this circuit is the one which the fault is on. So from this point now, I need to start delving around in the circuit in the building. But that's the beginning of the process for our fault finding on an insulation resistance.